Density or heat maps are quite a common way to display patterns. When we're talking about density maps, we're talking about a different thing than dot density maps. And as you'll see, they're made in a completely different way. With density or heat maps, we begin with known point or possibly line data. So we know either where things are located, sometimes it's just where the location of a point is, or other times it's some attribute associated with each of those points. Based on those points, we create a grid. So we're going from point data to a grid data. So something like individual points to something that's continuous, like a digital elevation model. And we do this by estimating the values in between the points by a process we call interpolation. Once we have this grid, then we can do all sorts of things with the grid. We can display the grid in different colors to represent where the hottest or the greatest amount of density of some information is, or we can even show it in 3D. So the thing that we're showing here could either be how many things are, where most of where there's kind of a clustering of points, or where those points are coming together, or it could be some attribute value associated with those points that we're mapping. Let's take a look at some maps. If you ever go into kayak.com and you're looking for a place to stay, you might see a heat map that looks like this. So this is for New York City. We can see St. Patrick's Cathedral here, the New York Public Library here, the Chrysler Building here. And you can click on these different buttons where people are going to do sightseeing, where people are going to eat or shop, or for nightlife. And these patterns will change as you do that. It's based on information that's been gathered about where people are doing different things. And we can see right, they're not individual points. It's just kind of like this pattern from red down through orange and yellow and green. And the more people are there, the more people are going to the Chrysler Building, the hotter this area would be. And that's why they're called heat maps. They're typically displayed in some kind of thing where red is on this side of the map, and that's the area where the density of people or the density of sightseers is, in this case, is the greatest. So how do we do this? So once again, we start with point or potentially line data. So these would be the input points. We might just be saying, where are most of these points located? We can see that maybe if there's just one point, maybe it just kind of shows up very faintly. But if we start getting more than one point clustered together, then it starts getting darker. And the place where the most points are clustered here, and even more so here and here, we get the darkest colors of all. We can also see that the patterns in this grid on this interpolated surface here somewhat match the patterns of where the points were to begin with. So basically, for each of these areas here, we're saying, okay, at this grid cell, how many points do we have close by? And we're just summing that and putting a value here, which would then translate into a value here. If we have information along roads and things are varying along roads or between roads, then we can come up with this sort of heat map, where perhaps this is where people are speeding. So maybe more people are speeding in this area here or through this intersection here. So it can vary right along the road, or it could vary between roads where one road has more stuff going on and another road has less stuff going on. But this would be a continuous grid. Even where there are no roads in this case, we would still have grid cell values here. It's just that they would tend to be very low because we're so far away from the roads. Just like if we're away from the points here, we also we still have values here, but they're values of 0 because we're away from the areas where the points are most dense. One thing this is used for a lot is crime mapping. So as we can see, this is homicides in Chicago. And we can see if we're getting this sort of clustering of data, if we're getting these dangerous areas, then this heat map is getting into darker and darker colors here. There's no clustering outside of the area where there are murders in this case here. And there could even be islands in there where that might be a little bit safer because all the murders are happening around that area there. But in ways like this, we can start once again with point data, interpolate a smooth surface, so kind of once again like a digital elevation model. And these even look somewhat like contours. We can see how they're getting higher and higher as we get to the most dangerous areas here, the place where the most homicides are occurring. So that because now we've gone from point data to a grid like a digital elevation model, if we wanted to, we can also display density or heat maps as a 3D map, just like we would display elevation. So in this example here, we've made a density or heat map. These would be the hottest areas here, but we're looking at it from the side. So these are also the highest areas. They're like high hills in an area that's otherwise flat. They're pointing out where the hottest area is, or the most dense area. And these things do tend to be clustered in particular areas. And sometimes those clusters are close to each other. If they're close enough, they can kind of form like a two humped type hill here. But we're able to see those patterns easily in 3D if we sort of turn the map on its side.